Good morning or afternoon or evening. This next section is looking at exponents that are negative, exponents that are zero, and using the quotient rule to simplify numbers with exponents. So let me quick kind of overview what negative and zero exponents mean. So if I start with some positive exponents here, let's say 2 to the third, that's going to give us 8. 2 to the second, that's going to give us 4. And 2 to the first is going to give us 2. Okay, so notice what's happening to our numbers here. 8, 4, 2. Okay, and they're going in half. And if I go 2 to the 0 power, following that same pattern, you would think, most people think 2 to the 0 would be 0, because it would be 0 2's. But following the pattern, we're going 8, 4, 2. We're going in half every time. 2 to the 0, anything to the 0 is actually 1. Okay, and then along those same lines, 2 to the negative 1 is half of that, or 1 over 2. 2 to the negative 2 is half of that, or 1/4. Okay, and what that negative exponent does is it essentially, 2 to the negative 3 there would be the same as 1 over 2 to the third. Okay, so that negative puts it in the denominator with a positive exponent. So 2 to the negative 3 is the same as 1 to the 2/3, which is still 1/8. So that pattern fits every single time. We're always, as we reduce the exponent by 1, we're going down by half. So 8 to 4 to 2 to 1 to half of 1 is 1/2. Half of 1/2 is 1/4. Half of 1/4 is 1/8. So that's what those negative exponents do. There's a pattern to everything. Okay, so the most important thing here to remember is anything to the 0 power, whether it be 5 to the 0 power or 100 to the 0 power, is always going to equal 1. And a negative exponent is the same as 1 over that number to a positive exponent. So in other words, 2 to the negative 3 is the same as 1 over 2 to the third. Okay, so let's look at a couple of examples here. All right, negative 9 to the negative 3. Remember what that negative 3 does? It puts it over 1, and then we have negative 9 to the positive 3 power. So the negative exponent becomes positive, but it goes in the denominator. So a negative times a negative is a positive, times a third negative would give us a negative, because this is not asking us for an answer. It's just asking us if it's negative or 0. So negative 9 times negative 9 times negative 9, 3 negatives, that would give us a positive answer. And I'm not going to do that in my head right now, but it's not asking us for an actual number. It's just asking us if it is, if it's positive or negative. And 3 negatives, negative times negative, is going to be a negative answer. Okay, so all we need to know is that that's going to be negative. So let's take 2, for example. Negative 2. So negative 2 times negative 2 is positive 4, times a negative would be a negative 8, times another negative 2 would be a positive 16. So when you have an odd exponent, the negative remains. If you have an even exponent, the negative changes to positive. Okay, so along those same lines, if I've got negative 7 6 times, that's an even exponent, so that's going to be a positive answer. Okay, so negative numbers to odd exponents are negative. Negative numbers to even exponents are positive. Okay. All right. So as we talked about before, anything to the 0 power is 1. So there's a couple of quick examples here. Okay. 4 to the negative 2. Remember what that negative exponent does. It is going to be 1 over 4 to the second power. So it puts it on the denominator and gives it a positive exponent. That would be 1 over 16. All right, and again, with a negative exponent here, that's going to put it flips things over. So this 4 here was, the 4 over 1 was flipped over to 1 over 4. Same thing when we have a 1/3. Um, so the negative exponent is going to flip it. So instead of 1 over 3, it's going to be 3 over 1, or just 3 to the third power. And that would be 3 times 3 is 9, times 3 more is 27. Okay, so the negative flips it. Okay, so division. If I have 5 to the second power divided by 5 to the third power, 5 to the second power divided by 5 to the third, that's going to look like this. 5 to the second would be 5 times 5. 5 to the third is 5 times 5 times 5. And as we recall, anything in the numerator and the denominator cancels out if it's the same. So 5 over 5 cancels, 5 over 5 cancels. So this simplifies to 1 over 5 as our answer. Another way of thinking of that is 5 to the second over 5 to the third. Let me turn that light on. Okay. Is the same as 5 to the 2 minus 3, which is negative 1. Okay, so in other words, instead of writing an expanded form every time like this, just realize you can just subtract your exponents, the top exponent minus the bottom exponent, assuming they have the same basis. So they both have to be 5 in order for that to work. So we subtract the 2 minus the 3 here. That gives us 5 to the negative 1. 5 to the negative 1, we recall, is the same as 1 over 5, which was the same thing we got up here. Okay, so I just wrote it in expanded form to show you what's happening. But all you need to know is that you can subtract your exponents there. Okay, so along the same lines, if I have 12 to the negative 14 over 12 to the 9, instead of writing that in expanded form and writing all those 12s, all I have to do is I have to do 12 to the negative 14 minus 9. And that would give us 12 to the negative 23, okay, which is the answer, but this says use only positive exponents. So to write that as a positive exponent, remember we have to flip it. Instead of 12 over 1, it would be 1 over 12 to the 23rd power. Okay, so you can either write it this way, I believe, or you could write it as 1 over 12, the entire thing to the 23rd power. I'm not sure what Math Excel likes better, but we can try that out. All right, I'm almost done here. Okay, so 5 divided by s to the negative 9th. Oops, not 19th, 9th. Okay. And this says use the quotient rule to simplify the expression. Okay, so instead of s to the negative ninth, I'm going to change that to a positive, and I'll flip it from the bottom to the top. So that would simply become 5 to the, 5s to the ninth. So I changed the exponent to a positive. When you change the sign, it flips it from top to bottom or from bottom to top. So that would be 5s to the ninth. So we're simplifying this, and the part of the directions I left out is we got to simplify and use only positive exponents. So if I have 7 to the negative 6th, I would change that to positive 6, but if that changing the sign flips to the bottom, and changing 8 to the negative 5th to a positive flips it to the top. So when you flip the sign of the exponent, you got to flip from the numerator to the denominator. Okay, and just one more, and then I'll wrap things up here. X to the 6th to y to the negative 3. Okay, so the x to the 6 is fine. It's got a positive exponent. We got a y to the negative 3. So that's just going to be a y to the positive 3, but it's going to be on the bottom. So I flipped it from a negative to a positive, which put it on the bottom. Okay, so that's a quick overview. If you have any questions, let me know, and I will be able to answer your questions in class. Okay, good luck.